Hi everybody, my name is Jette Nielsen. My research proposal is about the effect of microplastic and nanoplastic on coral ingestion and photosynthesis. My target audience is high school kids and the content and level is adjusted to it. Hope you will enjoy! Hi, my name is Jette and I'm a postgrad at JCU. I'm going to tell you about plastic eating corals today. Plastic is found in everything we use, from industrial products, makeup, clothes, and household items. The plastic industry produces plastic every year, about 280 million tons. Sadly, about 53 million tons end up in the sea. This is affecting not only the bigger marine animals that get caught or eat the plastic, it is also affecting the small organisms. Plastic is very slow to decompose. Therefore, it will degrade into smaller and smaller pieces instead of disappearing. When fish eats the plastic, they are unable to degrade the plastic in their body. And then comes along a bigger fish and eats it. The bigger fish eats many fish and thereby also eats a lot of plastic. This continues to happen all the way up in the food chain. Corals are just as affected as other organisms. The microplastic gets ingested by the corals and then they can't get rid of it again. Furthermore, the zooxanthellae in the corals, which let the corals perform photosynthesis like plants, might be absorbing nanoplastic, and these can block the sun out, so it can no longer perform its duty. So, my research is about finding out if corals have trouble eating regular food after they have eaten plastic. And also to find out if zooxanthellae is absorbing nanoplastic like some algae have been doing. First, I had to do a lot of research on what other experiments that have been done on the subject, which was not a lot since it was a very new area of research. But I did find out that the corals indeed did eat plastic, and some algae was capable of absorbing nanoplastic. So why not the zooxanthellae? Then I had to design the experiment, so I got some tanks and collected some corals off of Alvarez Island. Next, I had to let the corals rest for 8 weeks so they could get acclimated. For the first experiment, I exposed the corals for microplastic for 48 hours. Thereafter 48 hours with a clean tank and no food to make them hungry. After that, I fed the corals with regular food and measured the feeding rate by running water samples through a particle counter every half an hour for 6 hours. This would tell me if the corals were removing food from the water and thereby eating. In the second part of the experiment, after I fed corals with nanoplastic, I took some coral polyps out of the coral and looked at the zooxanthellae with a UV spectrophotometer, which sends light through the tissue and will tell me if the plastic particles are hiding in the zooxanthellae and how much. To measure the zooxanthellae's ability to photosynthesis before and after the exposure to nanoplastic, measurements of oxygen and carbon dioxide levels are done. If carbon dioxide levels goes up and oxygen goes down, it indicates that respiration is going on and photosynthesis has halted. So, why is this important? If corals have trouble getting their nutrition because they are eating plastic, they get stressed and they can make them more susceptible to disease and weaken their defense mechanism, and eventually they will die. The same is the case if the corals no longer are able to take advantage of the sun and make energy from sunlight, because the light receptors are blocked by plastic. Usually they only use respiration at night when there's no light, but if they are forced to do this all the time, they will get stressed. It is still unknown how much damage micro and nanoplastic is causing the corals, but we do know that other marine organisms are suffering from internal abrasion, blockage, and toxicity due to the plastic itself and the chemicals in plastic. It is important to do more research on how plastic is affecting the ocean and the animals living in it. And since we are producing so much plastic, we need to find out which consequences it has. This research can help in future pollution management, and the more we know, the better it is. Hope you have enjoyed getting more familiar with the research, coral and plastic, and why it's important to do research. And the next time you see a plastic item floating around in the ocean, pick it up and save a coral.